Hi guys, in today's video we are going to be reviewing some domain and range and then also pull in the interval notation that we worked on last lesson. So what I need you to make sure you have all of these materials. You picked up a note packet that looks like this. You picked up an envelope template. You picked up a page of graphs. And you picked up this little guy, which I'll explain a little bit more in a second. What I need for you guys to do right now is to make sure you have scissors and glue and go ahead and pause the video and start cutting these things out. So once you have everything cut, this is what you should have. So we're not cutting anything on the white note outline, but you're going to cut all the way around the template, the envelope template. You're going to cut each one of these 12 graphs apart, so you should have 12 different graphs. And then you're going to cut this little guy in a window type format. You have finished cutting everything out, so a couple of things to help us put all of this together now. So you have, it says glue D and R window here, so that's going to be this little guy right here. What I need you guys to do is only put glue on this square here in the middle, and then we're going to actually glue that down like this. And what's going to happen is we're actually going to take these and bring these in like that. Okay. So, again, only put glue in the middle square, flip it over, glue it down, and then these guys should be free to move. Then we have our envelope here. So with the envelope, what you're going to do is only put glue in this middle rectangle. Oh, sorry. Yes, no, you are. You're actually going to put glue in the middle rectangle here, and then also you're going to put glue here and here. So this is how this one's going to work. This is what you're going to glue down on the paper. These guys are actually going to glue to this. So watch the magic here. We're going to flip it over. This guy's going to come up like this. These little tabs come in like this. And of course, you have glue here. You're going to bring this like that. And then you're going to make sure there's some glue back here. And we're going to put it down there. And then once we put all of our graphs, once we're finished with our graphs, they're going to go in that little pocket. You can fold the pocket shut. Ta-da! Double check before the glue dries. Do you have only that one square glued down where you can open this guy up? And do you have an envelope pocket here? And then we can fold this shut. If you do, then you are ready. Welcome to your domain and range review notes. So what I have at the top of the first page is hopefully an acronym that will help you to remember domain versus range. So that's why I kind of have the little darker line right here through the middle. So D obviously is going to stand for the domain. You guys can write that in on your notes. The domain is the input value. So whatever that domain variable is, that will be what we are inputting into the function or into the whatever formula or function we are using. And it is usually the x coordinates or the x variable. Okay, let's see what else we got. The range. Range is going to be the opposite. So R is for range. Range is the output. So we put a number in, we get an answer or a number out, and this is going to be the y coordinate. All right, and then I have a little bit of stuff for you guys to write down here. All right, domain is the set of inputs or x coordinates. The range is the set of outputs. Okay, so your note page is going to look similar to this. I need you guys to add two definitions into your note page. So first we're going to talk about a relation. So a relation defines the relationship between two different sets of information. Usually in math, that set, those two different sets of information are usually going to be your x and your y, your domain and your range. Okay, usually that is how we're going to apply the definition of relation. The other definition I need you guys to add is for function. A function is a specific kind of relation that does not have any repeating x values used. And I put vertical line test in there. Hopefully some of you guys remember using the vertical line test in testing to see if a relation is a function. So all the relationships between two different sets of numbers are relations, but some of those relations are special because they are actually functions, which means they do not use any x values repeatedly. So if they use an x value, it's only used once. So go ahead and make sure you have those two definitions down for me real quick, and then I want you guys to add a couple of things to your domain and range window that I had you guys put on here. All right, your domain and range window. So the idea behind this is we're going to be able to take graphs and put them into the window and actually visualize or see our domain and range values. So what I'd like for you guys to do on the two side pieces of your window, I need you guys to write domain. So you're going to write the domain on the two edges here. And then obviously these two are going to talk about range. So domain is our x values, range is our y values. So domain, we're going to go from left to right, and range, we're going to go from bottom to top. So go ahead and write that in on each one of your windows for me. And then we're going to open our windows up, and if the domain goes all the way to the left forever and ever, it's going to negative infinity. So I want you guys to add a negative infinity on the inside of this window, a positive infinity on this side. So if the graph goes forever in the right direction, we're going to positive infinity. Similarly with range, if it goes forever down, we're going to be talking about negative infinity, and forever up, we're talking about positive infinity. So your window, when fully open, should look something like this, where you have negative infinity, positive infinity, and positive infinity. I need you guys to find this graph out of the 12 that you cut out. Now do keep in mind some of these look similar, so you need to make sure the numbers are up and down like this, not like this. So that's how you know you're looking at the graph correctly. I need you guys to find this graph, and we're going to stick it in here. We're going to start talking about the domain and range of a particular graph. Okay, so go ahead and put the graph into the window for me, and then we're only going to be talking domain at first. So the way we determine the domain when we're given one of these graphs is we're going to take the edge of our window and we're going to line it up with the furthest left value of the graph. Then we're going to take the right hand side and we're going to go to the furthest right hand value on the graph. And what you see there is the domain of the graph. So what's the farthest left number that we see? Well, that should be a -5. Farthest right value we see is a +5. So that tells me my domain is going from -5 to +5. That is our domain. Now there's a few different ways that we've learned how to write that. We can write that as an inequality. We could build that into set notation. And then we could also write it as an interval. So that's what we're going to be practicing on today. But right now I just wanted to make sure you guys understood how to use the window to help you figure out the domain. So domain here and here, you're going farthest left and stop, what value you see. Farthest right and stop, what value do you see? So domain for this one again is -5 to 5. We'll write that in our notes in just a second. All right, so open this guy back up. Let's talk range now. Range, we're going to go from the bottom. So we always start on the bottom on the range. So what's the lowest down point? We actually have 2 of them here, so 2 low points here, and we'll talk about that in a minute. All right, and then we're going to go up to the top. What's the highest point? Okay, it is okay that there is not a big bold dot up there at the top. Remember, lines are made up of a bunch of points. So even though we have a dramatic point down here at the bottom where the graph actually stops, all of these guys right here are also points. So our range is going to go from -2 down here on the bottom up to +2 up here on the top. All right, again, range -2 up to +2. All right, hopefully everybody kind of understands how we're going to be using this little window. So what I'm going to ask for you guys to do is, as we're going through some of the problems, I'm going to ask you guys to go back and use the window, and then we're going to kind of start working on completing some of the problems in the notes. And I'm going to have you practice using the window, and then we'll write the things down into our notes so that hopefully you guys are able to get that visual. Okay. One more quick thing on here before we get into the rest of the pages of the notes. On your envelope, I know yours looks slightly different than mine. That's totally fine. I want you to write down the things we are finding on the graph is domain, range, and then function with a question mark. So that's going to be a yes or no. Is it a function? So that's what we're going to be answering in the next few problems using these graphs that we've been working on today. Okay, so we have a couple of other vocabulary words that we're going to cover that are on the next page of your notes. So I did leave technically page 2 of your notes blank. The reason for that is because you can tear that piece of paper apart and actually have your pieces of paper side by side, similar to what I have here in the video, to help us fill this stuff out as we go. So a couple of vocabulary words up here, and then we'll go ahead and start working on the domain and range of that first graph that we were using. So determine if the graph represents a discrete or a continuous graph. So discrete and continuous are two vocabulary words that represent the type of graph we're talking about. A discrete graph has gaps or holes, which is the opposite of a continuous graph. A continuous graph, basically on a continuous graph, you should be able to graph the entire thing without having to pick up your pencil. So I'm just going to write don't pick up pencil or pen. All right, so a continuous graph is going to go all the way through. You'll be able to do the entire thing without having to pick up your pen or your pencil. All right, we're going to write the domain and range in interval and set builder notation. Remember, interval notation was using, I did not give myself enough space here. Interval notation was using our brackets or parentheses with a little comma in between the two numbers, so your start and your stop. Set builder notation, remember set or set builder is the one with the squiggly brackets. So you were given this graph. We already kind of played with it in the window just a little bit, and when we did that, we determined that the domain is going to go from this number right here to this number right here. Okay, so I think that one's easier in interval notation, honestly, than it is in set or set builder notation. In interval notation, what's our start? What's our stop? How far to the left? How far to the right? So the domain for this guy would be from -5, comma, 5. We go from -5 to 5. That's what we did on the window when we folded the pieces over. Now the -5 is an open dot, and that is the only -5 that we are using. So we're going to use a parenthesis here. The 5 is the closed dot or the colored in dot, so we're going to use a bracket here. All right. In set or set builder notation, squiggly bracket, we're talking about domain, and remember we just said domain is the x value, so we're going to say x is such that, and x is everything in here in between the -5 and the 5. So we're going to say -5, x, and 5, and then which one is bigger, the -5 or the x? Well, this is x, this is -5, so x is bigger, so we're going to do a less than sign. Alligator's eating the x, right? Not equal to, we have a parenthesis here, we have an open dot here. And then we have the 5. Between the x and the 5, which one is bigger? Well, here's x, here's 5. Remember, the farther to the right you go, the bigger we get. So x is going to, or sorry, the 5 is going to be bigger than x. This one is equal to, so we're going to draw the equal to underneath. So that would be it for our domain for this particular graph. Now let's take a look at it from a range standpoint. So range, let's see, the bottom of our window was down here, kind of lined up with this dot and then also with this dot over here. And then the top went right across here. So there's our range values. So what's the lowest value we're going? Well, it looks like the lowest we're using is a -2. And then the highest we're using is a +2. Now on the -2, is there any particular place where we are equal to -2? I know there's an open dot here, but there's also a closed dot here. And this little line right here is made up of a bunch of dots, a bunch of points. So these are actually all like little closed dots right in here. So it's actually a lot of places where we do equal -2, even though we don't necessarily equal -2 here. So we are equal to -2 somewhere along that Y line. So we're going to do a bracket for equal to. And then up here at the top, the 2, are we equal to 2? Well, yeah, there again is a line right across here, which is a whole bunch of little closed-in dots, points. So we are also equal to 2. All right, so put that in set builder notation. This time we're talking about range, so what variable am I using? This time we should have a Y. Okay, so -2 and Y and 2. Close it with a squiggly bracket. Again, this time we're going from bottom to top, so all of this here in the middle represents the Y values. So is Y bigger or smaller than -2? So Y is bigger than -2, so we're going to use a less than symbol here. We were also equal to, because we had points down here, we also had a bracket here. Okay, between the Y and the 2 up here, which one is bigger? Here's Y, here's 2. The further up we go, the bigger we get. So the 2 is bigger, again, equal to. Okay, so now we need to answer the question, is it a function? So the way we determine that is with a vertical line test. Basically, we said in our definition on the front page, a function means we are not reusing any x values. The way we test that on the graph is we're looking to see, did I ever make x values used more than once? And the way we can tell that is we take our vertical line and we're going to drag it across the graph. And as long as it's only touching one point on the graph at a time, and I know because I have all my colors in there, it may be a little bit hard to tell, but you can use your pencil or you can use the edge of a piece of paper, and there is no time where my line is touching more than one point of this graph at a time. So is this one a function? Yes, this one is a function. It does pass the vertical line test. And then I realized I skipped my first question up here, which is discrete versus continuous. Can I draw from this point to this point, so from beginning to end of the graph, can I draw it without picking up my pen or my pencil? All the way across. So yes, I can, which means this is a continuous graph. Okay, problem number 2, and I'm not necessarily going to do all the problems that are on your note page. I actually want you guys to do some of those independently, but we're going to do this graph next, which is the next one on your notes. So if you can find this graph in your set of graphs that you cut apart for me, then we need to talk about domain and range on this graph. So give you a quick second, try to find that, or pause me if you need to pause me. Find that graph for me real quick. All right, so let's talk about domain first. So we're using our left and right flaps to get our domain. So when we're folding these guys in, we want them to touch a point and not an arrow. So this guy is just fine over here, but over here, it's touching an arrow. And anytime either one of our flaps, domain or range flap, touches an arrow, we're going to open it up. So this tells me the domain is going to go from -infinity, and we can follow the graph because this arrow is going to go forever and ever this direction. So we're going to follow the graph from -infinity, and then it stops at 4. So our domain is going to be from -infinity to 4. Again, when one of your flaps touches an arrow like this one does here, we're going to open that flap up, and it means that we're going to an infinity. In this case, a -infinity. So let's write that in on our next problem down here. So for our domain, we said we're going from -infinity to 4. Now, if you'll remember, when we were talking about infinities on interval notation, you do not ever equal infinity. So we show that by making a parenthesis here. On the 4 is a colored in dot, so we're going to use a bracket here. All right, what does that look like in set notation? So we're going to do squiggly bracket. We're talking about domain, so we're going to use an x value such that, okay, the only values I have here are x and 4, and we need to determine which one is bigger. So remember, the line or the squiggle represents x. So here's x, here's 4, 4 is bigger, alligator is going to eat the 4. We are equal to, because I have a colored in dot down there on the 4, and close it with a squiggly bracket. All right, so let's give range a shot for this one. So again, same graph that I have going on here. We're going to come from the bottom and bring this little guy up like this, and it's going to touch right there. That is the dot that we're working to line up with. From the top, we're going to come down, and the first thing that my flat will touch is an arrow. So just like we did for domain, if the first thing you run into is an arrow, you're going to open it up, and that's going to tell me we're going to infinity. So this time my range from bottom to top, I do have a bottom value, but this time I don't have a top value. So we're going up to the range is infinity. So this one, what is the y value of that point? And don't tell me 4, because 4 is the x value. So the point here is 4, 0. So we need to look. Sorry guys, you're going to have to forgive me. I'm having to do a voiceover because my audio quit. So to finish this one up on the range, we were talking about going from 0 up to infinity. Remember, you're going from bottom to top. So as I write the range on this one, 0 is our start. I wrote 4 because I was thinking 0 and 4, like that's not right. So we're going 0 to infinity would be our range value for this one, because we're starting at a value of 0 and working our way up to infinity. 0 does have a closed-in circle, so we're going to use a bracket. Infinity always uses a parenthesis. So to write that one in set notation, we're going to use y such that the only values we're using are y and 0. Now which one is bigger? We're working from the bottom to the top. 0 is smaller than y because y is above it. So alligator is going to eat the y. We are equal to, so we put the equal to symbol underneath it. Now we need to talk about discrete versus continuous and whether or not it is a function. So I'm pulling down my line over here to give us a vertical line test. The vertical line test, we're passing that vertical line all the way across the graph. It is not touching more than one point on the graph at a time. So yes, it is a function. And then can we draw the entire graph without picking up our pencil? Yes, it does not matter whether you start on the left or on the right. You can still draw the entirety of that graph without picking up your pen or your pencil. So this is a continuous graph. All right, we're going to try another graph now. So if you guys would go ahead and find the graph in your stack that looks like this. It's basically a vertical line going up and then another vertical line going down. So that one I believe is on the second page of your notes. So go ahead and give that one a dig around, find that one for me, and let's see if we can figure out domain and range for that one. Okay, so when we set it into our window, again, we're doing domain first. Because there are two pieces, it's just like what we were doing when we were using the number line before. You're going to have to look at it as two separate pieces and then end up having two separate intervals or two separate inequalities in your set notation. It looks like I was answering the part about discrete. Obviously, with it being two different parts, it is going to be a discrete graph, not a continuous graph. There is the gap in between the two, so that's what makes it discrete. But now I'm bringing the domain window over. It looked like we stopped that domain window at -3 on both sides, right? So the x value is not only being used, the only x value that's being used is a 3. Sorry, -3. Goodness. All right, so then we look at the other part of the graph, and I'm only using a 2 on the other part of the graph. That's what I'm doing here, is showing you that we're only using an x value of 2. So then what that means as far as the domain is concerned is we're only using two x values. We're using an x value of -3 and an x value of 2. So typically we don't do an interval if an interval is not showing us a spread of numbers. And up here I scrolled back up because I thought I had put write in interval notation if possible, because sometimes it's technically not possible to write interval notation. Intervals show a spread of numbers. I'm going from this number to this number. If I'm not going from a number to a number, then there's not really an interval, so there's no need for the interval notation. Now, I showed you guys, like, on your notes, we did do like on the worksheet, we had an interval like that, and typically you don't write an interval with the same number for the left and the right, so that's why I'm erasing that. I put that on your worksheet just to kind of illustrate a particular point. Okay, so no interval notation, but we can do set notation. Again, domain, so x such that x is, and what we're going to do here is just say x is this number and this number. So the only two numbers I'm using are -3 and 2. And I did write down -2. I had it in my head that it was a -2 for some reason. I do go back and fix that a little bit later on in the video. So the domain actually should be -3 and 2, not -2 and 2. No idea what else I was saying here. Sorry. I know the audio is going to be a little bit off just because I'm not recording and talking at the same time because I'm having to redo the audio here. All right, so we're talking about range. Range, we're going bottom and top. I actually started on the top on this one. Just looking at the very top piece, we're hitting an arrow on that top piece, which does mean we're going to infinity. From the bottom, if I come up from the bottom, the first number that I'm going to hit, it looks like it's going to be maybe a 2. So we're going from 2 to infinity on that section of the graph. Again, 2 pieces of the graph, so we're looking at 2 different intervals. We will be able to write an interval for this one because there is a spread of numbers. For the part that's on the left side of the graph, we are hitting an arrow on the bottom, so we're going -infinity. And we go up to 2. So one part of the graph went from -infinity to 2. The other part of the graph is going from 2 to infinity. So I'm going to write it in one way first as far as the interval is concerned, and then kind of explain that we can actually combine those 2 intervals together. There's not a reason to have separate intervals in this particular case. So again, one of the intervals was -infinity to 2. The 2 is a colored in dot, so we're going to use that closed bracket. And then the other interval was from 2 to infinity. Now the reason we would have 2 separate intervals is because there was a break in the values that we're using. But in this particular case, we go from -infinity to 2 and 2 to infinity, but we're using that 2 both times and we're equal to both times. So we can actually combine these 2 intervals into one and just say the interval is from -infinity to +infinity. In other words, there's no gap in the y values. I'm using all the y values from -infinity up to +infinity. So what I want you guys to write on your notes is from -infinity to infinity. Okay, we talked about this notation. When we say that we're using all the numbers, we're going from -infinity to infinity, what we're saying is that we are using all real numbers, all the values from -infinity to infinity. So when we go to write this in set notation, we're still using y such that, and because y is using all the values, we're going to say y is all real numbers. -infinity to infinity, in set notation we say all real numbers, which is the R with the 2 bars. And I went ahead and wrote in all real numbers, just to help you remember that. All right, next question. Is it a function, yes or no? Well, we actually technically have 2 vertical line segments here. So each time you have a vertical line, it won't pass the vertical line test, which means no, this is not a function. We're actually reusing x values multiple times on both of these line segments. So this is not a function. All right. So here's our next graph. I believe this one is going to be on the last page of graphs that you have in your notes, but go ahead and stick that one into your domain and range window, and let's see if we can do the domain and range for this little guy. So again, starting off with domain, we're going to go left to right. So slide that left side of the domain up until you hit that very first point, which it looks to me like maybe we're going to be on like a -4. And the right side, we're going to slide up to that point up there at the top. So our domain, it looks like on this one, is going to be going from -4 to +3. So pretty straightforward on this one, -4, 3. Now we just need to do brackets or parentheses. On the -4, that is a closed-in dot because it is a point. So it's not an open dot, so we assume it's a closed-in dot. The 3 actually is an open dot, and there's nowhere else that we are equal to a 3, so we're going to use a parenthesis on that one. Okay, turning that into set notation, we're going to do squiggly bracket, x such that. Remember, x is everything in the middle of the graph, so we're going to write a -4, an x, and a 3, and then figure out our less than signs from there. All right, so the x is bigger than -4, so the alligator is going to eat the x on this one. It is equal to, so we're going to put the equal to line underneath. And then x is going to be smaller than 3. This one is an open circle, not equal to, so we're not putting anything underneath that equals the inequality. All right, range, bottom to top. The bottom dot, the very lowest dot, is going to be at -5. The highest will be at +5. So this one, it looks like our range is going from -5 with an open circle to +5 with an open circle. Writing that as an interval, we're going to do -5, 5, parentheses on both because both have open circles. Set notation, y such that, so the y with the tall line, we'll write -5, y, 5. And then we just need to figure out our less than, greater than. So again, the graph represents your x and your y values. So y is in between -5 and 5. So if I'm talking about which one's bigger than -5 or the y is bigger than -5, but 5 is bigger than y. Okay, so now we're talking discrete versus continuous. This is a continuous graph because you can draw the entire graph without picking up your pen or your pencil. So this is continuous. But now if we talk about a function, yes or no, there's a lot of places on this graph where we end up using the same x values multiple times. And you can represent that using the vertical line test on your note paper. Or if you go back over to your window, you can actually use the side of your little domain foldable. Part of your window is actually going to be hitting the graph multiple times. So no, this is not a function. All right, the last graph that we're going to be working on is this one. In your notes, it's directly above the one we just got through doing. So go ahead and find that graph for me and put it into your foldable. And we're going to talk about finding the domain and range on this one. So you notice on this one, we just have a bunch of separate points. They are not connected, and so it would definitely be a discrete, we call this a purely discrete function because it is not connected at all. We have to hop from point to point to point. Okay, so what I was showing is kind of similar to what we had up there where we had to hop from one place to another. So I definitely would call this one a discrete graph. And this is where I noticed that I had made the mistake on this one and put a -2 instead of a -3. Okay, so with this particular graph, if we're looking at the domain, you're looking at each individual part of that graph as a separate value. They are not connected in any way. So I'm going to zoom in on the graph. If we were to connect the dots, say between the -3 and the -2, you would be indicating that all the values between -3 and 2 would be included in the numbers that we're using for x. Because there is no line between them, we are not using the values between -3 and -2. We are only using -3, the -2, then the other x values that these points are being represented by. So in order to do that as far as the domain is concerned, we are not going to have an interval because an interval, again, is a spread of numbers. It's saying from here to here. So no interval notation for the domain or the range on this one, just set notation. So we're saying x such that x is equal to, and then all we do on this one is just list the x values of each one of these coordinate points. For some of you guys, it might be easier if you actually list the coordinate points out, and then you can see your list of x values, and then we'll do the same thing for our range, and you can see the list of range or y values. And again, here for the range, we're just listing the y values. On the range, there is one repeated y value when I get to that point. So we do have what, a -4 looks like, -5. Okay, we have a y value of 0. We have two y values at 1. And there's no reason to repeat that. If we're using it, we're using it. It doesn't show how many times we're using it. So we are going to only write it once. And then we also have a y value of 4. Okay, to finish this one off, is this a function? Well, if you look at your x values, I did not reuse or repeat any x values. So by definition, that does make this a function. It is okay that I reused y values as long as I do not reuse any of the x values. So yes, this one is a function. Those are all the examples that we have for this video. What I'd like for you guys to do now is to go back through your notes and attempt using the window, some of the other points or some of the other graphs that you're given, attempt the domain and range, and then we will be able to check those to see how you guys are doing on domain and range.